Welcome to Intelligence Gateway. What are the different 5G deployment considerations? The different 5G deployment considerations include network architecture, spectrum allocation, security, and power consumption. Network architecture considerations include the use of virtualization and cloud computing to provide greater flexibility and scalability. Spectrum allocation considerations involve securing sufficient spectrum for 5G networks and managing interference. Security considerations involve protecting the network from cyber threats, while power consumption considerations involve managing the energy requirements of 5G equipment. What are the different 5G network optimization techniques? The different 5G network optimization techniques include beamforming, network slicing, edge computing, and advanced antenna technologies. Beamforming involves directing radio signals toward specific devices, while network slicing involves creating virtual networks to support different use cases. Edge computing involves processing data closer to the source to reduce latency, while advanced antenna technologies, such as massive MIMO, can enhance coverage and capacity. What are the different 5G network planning techniques? 5G network planning involves determining the optimal network configuration and coverage to meet the performance requirements of the 5G service. The following are the different 5G network planning techniques. Coverage planning. This technique involves determining the optimal locations for 5G base stations to ensure complete coverage of the target area. Capacity planning. This technique involves determining the required network capacity to support the expected number. Frequency planning. This technique involves selecting the optimal frequency bands and channel bandwidths to provide the required coverage and capacity. Network slicing. This technique involves partitioning the network into virtualized, independent networks that can be customized to meet the specific needs of different applications and services. Interference management. This technique involves minimizing interference between adjacent cells and neighboring networks to ensure optimal network performance. What are the different 5G network design techniques? 5G network design involves selecting and configuring the network components to provide the desired performance and functionality. The following are the different 5G network design techniques. Radio Access Network (RAN) design. This technique involves designing the base station architecture, antenna configurations, and radio resource management strategies to provide the required coverage and capacity. Core network design. This technique involves designing the network core components such as the core network nodes, gateways, and network functions virtualization (NFV) infrastructure to provide the required network services and functions. Transport network design. This technique involves designing the transport network components such as fiber optic cables, microwave links, and routers to ensure low latency and high bandwidth connectivity between the base stations and the core network. Security design. This technique involves designing the network security features such as authentication, encryption, and access control mechanisms to ensure the confidentiality and integrity of the network data and services. What are the different 5G network rollout techniques? 5G network rollout involves deploying the network components and infrastructure to enable the delivery of 5G services. The following are the different 5G network rollout techniques. Greenfield deployment. This technique involves building a new 5G network from scratch in a new geographical area. Brownfield deployment. This technique involves upgrading and expanding an existing 4G per LTE network infrastructure to support 5G services. Small cell deployment. This technique involves deploying small cell base stations in densely populated areas to provide localized coverage and capacity. Dynamic spectrum sharing, DSS. This technique involves sharing the spectrum resources between 4G per LTE and 5G networks to maximize the utilization of the available spectrum and minimize network downtime during the transition period. What are the different 5G network maintenance techniques? 5G network maintenance involves performing regular maintenance activities to ensure the optimal performance and reliability of the network. The following are the different 5G network maintenance techniques. Preventive maintenance. This technique involves performing routine maintenance activities such as cleaning, inspection, and testing of the network components to prevent system failures and downtime. Corrective maintenance. This technique involves fixing network failures and issues such as hardware failures, software bugs, and configuration errors. Predictive maintenance. This technique involves using data analytics and machine learning algorithms to predict and prevent network failures based on historical data and network performance trends. Proactive maintenance. This technique involves identifying and addressing potential network issues before they occur based on real-time network monitoring and analysis. What are the different 5G network upgrade techniques? Several techniques can be used to upgrade a network to 5G, some of which include non-standalone (NSA) to standalone (SA) migration. This upgrade technique involves upgrading the network from 4G to 5G in a phased manner. The first phase involves upgrading the radio access network (RAN) to 5G, while the core network remains on 4G. The second phase involves upgrading the core network to 5G, making it a fully standalone 5G network. Dynamic spectrum sharing, DSS. This technique enables 5G to share the same spectrum with 4G, allowing the network to offer 5G services without the need for an additional spectrum. Massive MIMO. This technology increases the number of antennas on the base station, allowing for more data to be transmitted simultaneously, resulting in faster data speeds and improved network capacity. Network slicing. This technique enables network operators to create virtual networks within a physical network, allowing them to provide customized services to different user groups. Cloud-native architecture. This technique involves migrating the network to a cloud-native architecture, which enables network operators to automate network management and scaling, resulting in better network performance. What are the different 5G network monitoring techniques? The following are some of the techniques used for monitoring 5G networks. Radio frequency (RF) monitoring. This technique involves monitoring the RF spectrum for any anomalies, such as interference or signal degradation. Protocol analysis. This technique involves analyzing the communication protocols used in the network to identify any issues, such as packet loss or latency. Quality of service (QoS) monitoring. This technique involves monitoring the performance of the network in terms of QoS metrics, such as throughput, delay, and jitter. User experience monitoring. This technique involves monitoring the network from the perspective of the end user, using techniques such as crowdsourcing or user feedback. Network function virtualization (NFV) monitoring. This technique involves monitoring the performance of the virtualized network functions (VNFs) used in the network. What are the different 5G network troubleshooting techniques? The following are some of the techniques used for troubleshooting 5G networks. Fault management. This technique involves identifying and resolving faults in the network, such as hardware or software failures. Performance management. This technique involves monitoring the performance of the network and identifying any areas where performance can be improved. Configuration management. This technique involves managing the configuration of the network components, such as base stations or routers, to ensure that they are working correctly. Security management. This technique involves managing the security of the network, such as ensuring that firewalls and intrusion detection systems are functioning correctly. Service management. This technique involves managing the services provided by the network, such as ensuring that they are available and functioning correctly. What are the different 5G network performance metrics? The following are some of the performance metrics used to measure the performance of 5G networks. Throughput. This metric measures the amount of data that can be transmitted over the network in a given period. Latency. This metric measures the time it takes for data to travel from the source to the destination. Jitter. This metric measures the variation in latency over time. Availability. This metric measures the percentage of time that the network is available to users. Quality of service (QoS). This metric measures the performance of the network in terms of metrics such as throughput, latency, and jitter. Thanks for watching. For more information, like, comment, and subscribe our channel.